Welcome back to a new chapter, on to chapter 4. And with any new chapter, we start off with this 24 game. If you choose to play, then go ahead and give these a shot, and I'll go over the solutions. If not, go ahead and skip ahead to when we start 4.1 here in a couple minutes. But the solutions for these are, the first one here is 4 times 4 would be 16. 16 plus 8 would be 24, so 16 plus 4 would be 20, plus another 4 would be 24. This next one here, we can do 1 plus 9 would be 10, times 4 would be 40, minus 16 would be 24. Or another way would be 16 minus 9 would be 7, minus 1 would be 6, times 4 would be 24. And let's see what we have here. Oh, interesting. Okay, so this one goes up to 100. 10 times 10 is 100. Then minus 4 would be 96 divided by 4 would be 24. That's a tough one there. That's a hard one to find. And this one here would be another tough one. This one's going to be 16 times 9. 16 times 9 would be 54 plus 90, 144 divided by 6. 10 minus 4 would be 6. So 144 minus divided by 6. That's another hard one. So getting harder here as we get into these later chapters. But anyways, let's go jump into chapter 4, 4.1 specifically. And this is all about fractions. What is fractions? So you've probably already encountered fractions in previous math, but we're going to cover them again, just in case you haven't been exposed to them yet. So we know that 12 divided by 3 is 4. We know that 72 divided by 9 is 8. But what is 2 divided by 3? So first of all, when you see 2 divided by 3, what do you think? You should instantly start thinking, that is the number 4. When you see 12 divided by 3, that is the number 4. It might look like it's 2 numbers, but actually, you know that all this means is that it's 4. Just like this. As soon as you see this, you know that is the number 8. It's expressed differently, but that's just the number 8. But what is 2 divided by 3? Well, it's also a number. And the number is 2/3. That is a number. It's not an integer, but it does have its place on the number line. How big is 2/3? Well, if you know anything about fractions, or if you could just have an intuition maybe, you would know that 2/3 would be larger than 0. It's a positive number, right? But it's not as big as 1, because 3 divided by 3 would be 1. So 2 divided by 3 would be less than 1, right? So you probably know that 2/3, or 2 divided by 3, is a little bit less than 1, but is greater than 0, because it's not negative. All right, so then the top number we're going to call the numerator. The bottom number is going to be called the denominator as we go forward. And if you have 0 over a number, let's say 0 over 3, it's the same thing as saying 0 divided by 3. And we know with our divisibility rules, 0 divided by anything is going to be 0. All right, so kind of back to how big is this 2/3? So 2/3, you can see, is right here. And so what does that actually mean? So if we have 0 and 1 on the number line, and we split it into 3 sections. So we have this section here, it's 1, 2, 3. So it's split into 3 sections. And each one of those sections is going to be 1/3. So this is a third, this is a third, and this is a third. It's like if you cut it into 2 sections, if you have, let's say we have 0 here and we have 1 here, if you split it right in half, then this would be this section would be a half, and this section would be a half. So together you have 2 halves, and at this point that would be 1 half. And like here, you have 1/3, 2/3, 3/3. Same thing goes in the opposite direction. If we go negative, we go to negative 1/3, negative 2/3, negative 3/3, and you know, again, 3 divided by 3 is going to be 1. Negative 3 divided by 3 is going to be negative 1, and so on. And also there's a video for more fraction information down here. You can go check out in the description. There's a link there. All right, continuing on, there's some fraction facts that we want to remember as we move forward. So 0 divided by anything is going to be 0, assuming that a is not 0. Even 0 divided by 0, you still can't divide by 0. Self-division, a divided by a is always going to be 1, except again, when a is 0, you still can't do 0 divided by 0. Divided by 1, so a divided by 1 is just going to be a. And dividing into a negation, so a negative divided by a positive is going to be a negative, and a positive divided by a negative is also going to be a negative. A negative divided by a negative will be a positive. So important things to remember as we go forward. But getting started here on problem 4.1. So we're going to simplify each of these fractions using those rules from that last slide. So 0 over 7 is the same thing as saying 0 divided by 7. And we know, we just said that's going to be always 0. When we have 0 over anything other than 0, it's always going to be 0. All right, so we have self-division now. So this is the same as saying 5 divided by 5. We know self-division is always going to be 1. Anything divided by 1 is just going to be itself, so this is going to equal 2. All right, so 12 over 6 is the same thing as saying 12 divided by 6. And we could even use our updated definition of division if we want to. I know we already know the answer to this, but if you just want to remember and do some practice, we can do 12 times the reciprocal of 6. And then we know that 12 is the same thing as 2 times 6. So 2 times 6 times 1 over 6. And, well, we have our reciprocal identity. So we know that's going to be 1. And we're going to be left with 2. So 12 divided by 6, or 12 over 6, is going to be 2. All right, so negative 12 over 3 is going to be the same thing as negative 12 divided by 3. And we learned in the division section that a negative divided by a positive is going to be a negative, so we know it's going to be a negative. And 12 divided by 3 is going to be 4. Okay, for this one, there's a couple ways to do this. We could just add up the numerator. And adding up the numerator is going to be 35. Adding up the denominator is going to be, if you have negative 4 and you take away another 3, then this is going to be negative 7. Also, if you use our updated definition of subtraction, we know this would be negative 4 plus negative 3. And then we can extract out the negatives, negative 1 from that, and then we get negative 4 plus 3. And then we would get negative 7. So we could do that also. So we give you negative 7. And we know that positive divided by a negative is going to be a negative. So this would be negative 35 divided by 7 would be 5. So it'd be negative 5. Another way you can do this is you could rewrite this whole thing as division first. And you could say 22 plus 13. But be very careful with this, because if you want to rewrite this as division, this would actually not be correct. You could not do it like this. Negative 4 minus 3. This would not be correct. Why? Because remember your order of operations, which one would you do first? Well, you would do this first. You would do 13 divided by negative 4 first, and then you would not get the right answer. So if you're going to write it out in division first, make sure you put parentheses where you're supposed to. So all of this, 22 plus 13, is going to be on the left side of the division sign, and then this negative 4 minus 3 is going to be on the right side of the division sign. And then you'll get the same answer. You'll get 35 divided by negative 7, and then you will once again get negative 5. Okay, for what values of n between 1 and 40 is n over 7 an integer? All right, so if we do it's between 1 and 40. If we do 1 over 7, we know that that's not an integer. That's going to be between 0 and 1. Same with 2 divided by 7, 3 divided by 7, 4 divided by 7, all the way up to 7 divided by 7. And you know 7 divided by 7, or 7 over 7, 7 over 7 is self-division, and that's going to be equal to 1. And 1 is an integer. And what's the next integer going to be? Well, the next integer after 1, you know, is going to be 2. And so how would you make 2? Well, that would be 14 over 7. Because you always have to have over 7. This is what n over 7. So it would be 14 over 7 would be 2. And then what do you think the next one would be? If you said 21, you'd be right. So it's going to be 7, 14, 21. You probably recognize a pattern here. And you know the next one's going to be 28 and 35. So those would be the values of n that would make integers, and they are multiples of 7. All right, so each segment between two consecutive integers on the number line below is divided into 5 equal pieces. For each lettered dot, find a number that corresponds to the point on the number line. All right, so we see 0 right here, and 1 is right here. And it says that each number is divided into 5 sections. 1, 2, 3, 4, 5. All right, so let's start what might be the easiest one first, which might be B. All right, so if it's divided into 5 sections, then what does that mean? How big is each section? Well, if from 0 to 1 is divided into 5 sections, divided being the key word, then 1 is divided into 5 sections. And so this section is going to be one of those 5 sections, and this would be another one, and this would be another one. There'd be 5 of them. So there'd be 5 pieces of 5 in the whole. And so that would be 5 divided by 5 would end up being 1, or 5/5 would be right here, which means B would be at 1/5. We'd have 2/5, 3/5, 4/5, and then 5/5. All right, so we know B is 5/5, sorry, 1/5. What is A? Well, let's see, we could keep counting, so we know this is 5/5, 6, 7, 8, 9/5. So we can say A is 9/5. We also know that 2 is going to be 10/5, right? 10 divided by 5, 10 divided by 5, we know is 2. And if we kept counting, this would end up being 10/5, we know that. But we already knew that this would have been 10/5 because we know that 2 is going to be 10/5. So if we know that 2 is 10/5, we could have gotten there to A from 2, because we know you can go down 1, so it'll be 9/5. All right, so now let's go to negative. So these are also split up into 5. So this is going to be a 5th of negative 1. This is going to be another 5th. This is going to be another 5th, another 5th, and another 5th. There's going to be 5 of them, just like there was the other way around. But each one is going to be, it is going to be divided by 5, because this is divided into 5 sections. But we're going below, we're going left of the 0. So it's going to be going to negative 5 over 5 would end up being, negative 5 divided by 5 would be negative 1. So negative 5 over 5 would be negative 1. And so each of these would be negative 1/5. So negative 1/5, negative 2/5, and C would be negative 3/5. I know I'm going a little bit slow here, but I just wanted to drive the point home, and I know some of you might be more comfortable with fractions than others, so I just want to make sure that we're all on the same page with fractions before really ramping up, because this chapter is going to speed up quite a bit. So I want to make sure we have a good foundation. So again, at negative 1 here, we're at negative 5/5, and just like we did for A, continuing to count on, we can have negative 6/5 and negative 7/5. So D would be negative 7/5. Just to give you a heads up, you might have worked with mixed numbers when you did fractions before, and there is a section on mixed numbers here in chapter 4, but I will let you know that going into algebra, you won't really be working with mixed numbers very much. They can get confusing when you see something like 3 and 4/5, for example. This would be a mixed number. This would be 3 wholes and 4/5 more. This can get a little bit confusing sometimes when doing algebra, because if you have 2 variables like A, B, and they are touching like this, you know that's multiplication. This means A times B. And so if you wanted to show like 3 times 4/5, it can get confusing when you just write this 3 and 4/5. I mean, this is a mixed number, but you could easily mistake this for multiplication, saying, oh, this would be 3 times 4/5, which is very different than 3 and 4/5. But we'll get into that more later. All right, use a number line to explain why 3/7 is between 0 and 1. All right, so we'll use a number line, and we have 0, and we have 1. And we know these number lines go on forever. And if it's over 7, that means it's cut into 7 pieces. Let's see if I can cut this into 7 pieces. 2, 3, 4, 5. Oh, I didn't do very well. 6, 7. Okay, they're not exactly even pieces, but it should be 1, 2, 3, 4, 5, 6, 7 pieces in between 0 and 1. All right, so if there's 7 pieces between 0 and 1, what does 3/7 mean? It means there's 3 of those pieces, because if this is 1/7, and this is 2/7 and 3/7, it's this much. So it would be right here. This would be 3/7, which is indeed between 0 and 1. So another way to explain why 3/7 is between 0 and 1 is, the numerator is smaller than the denominator. So that means that it's less than an integer, right? So 7 over 7, would be 1. And so 3 over 7 would have to be less than 1. But how do you know it's greater than 0? Well, it's not negative. If it's not negative and it's not 0, then it's non-negative. And if it's non-negative and it is not 0, then it's going to be positive, and which means it's going to be greater than 0. All right, so between what 2 consecutive integers is 43 over 5. Okay, let's see how the book wants us to do this one, because I know my first intuition of how I want to do this, and that would be with division. But I guess we can kind of use our intuition and know that the integer closest to 43 over 5, we know it's going to be multiples of 5 are going to give us integers. So 5 over 5 will give us an integer, 10 over 5 will give us an integer, and we probably know that all multiples of 5 end in a 5 or 0. So we know that both 40 and 45 are both going to be integers. Right? So 40 over 5 is going to be the same as 8, and 45 over 5 is going to be 9. So I guess that's what they're looking for. What 2 consecutive integers is 43 over 5. So 8 would be the same thing as saying 40 over 5. 9 would be the same thing as saying 45 over 5. And 43 is going to be, somewhere around here, right? Would be 43 over 5. Would be somewhere in between 8 and 9. All right. So 4.5. Points A, B, C, and D on the number line below correspond to these fractions in some order. Match each point to the correct number. All right, so let's deal with this first one. This first one's pretty easy. And why is it easy? How does it stand out versus all of the other ones? What's the main difference with this fraction? And it's negative. So we know that here's the 0. So we know the only one that can be left of 0 is the only negative. So this one has to be negative 4 over 7, or negative 4/7. And does this make sense? So this is between 0 and negative 1. Does that make sense? Well, numerator is smaller than the denominator. So it does make sense, because negative 7 over 7 would be negative 1, and this is to the right of that. It's hard to say when you're talking about negatives. Using the words, it's bigger or smaller or more or less can sometimes get confusing, because this fraction is actually more than negative 1, right? Because it's to the right of negative 1. But this integer 4 is a smaller integer than the integer 7. So that's all I mean by that whole rant there. That so 4 over 7, if we ignore the negative sign, 4/7 is smaller than 7/7. So it's going to be before negative 1. All right, so how about to the right? So we have one of these fractions that should be between 0 and 1. And remember, if we know that the numerator is smaller than the denominator, then that would be smaller than 1. So do we have a fraction here with the numerator smaller than the denominator? And that would be this one right here, 4/8. So 4 over 8. And that would be between 0 and 1. Okay, so we have 1, and we have D here that's exactly 3. So do we have a fraction that is exactly 3? So let's just see if we can do some quick division in our head. Can we do 21 divided by 7? Is that something that we can do easily in our head? Yeah, I think so. I think that would be 3. So this looks like 21 over 7. If we would have started here, say, can we do 15 divided by 7 in our head quickly? No, we can't. That doesn't go in evenly. We can do 14 divided by 7, but not 15 divided by 7. So we did this one, we did this one, we did this one. The only one left is 15 over 7. So by default, this is going to be 15 over 7. But does it make sense for it to be a little bit over 2? Well, 14 over 7 would be 2. So 15 over 7, that is reasonable that this one would be 15 over 7. Always make sure that your answers are reasonable. It's very easy to just say, well, this is the only one left, so it has to be it. But that could be a very easy way to correct your answers if you had something wrong previously. If you get to that last answer and you put it in there and realize like, oh, that doesn't make any sense. Like what if we had put 21 over 7 here and realized that doesn't make any sense because that dot should be right on 3. Then you know you made a mistake somewhere prior to this. So careful with that very last answer instead of just, blindly just putting it in by default. Actually check to make sure that that final answer makes sense. All right, use the number line to explain why 4 over 8 equals 1/2. All right, so let's make a number line. It's going to be split up into 8 pieces. So let's do 0 and 1. Let's see if I can do better than last time. I'm going to be split into 8 pieces. So it's going to be 2 pieces, right? 1 and then 2, and then 3, 4, 5, 6, 7, 8. Okay, so it's a little bit better than last time. So this is 1, 2, 3, 4, 5, 6, 7, 8 pieces between 0 and 1. Good. All right, and 4 of those pieces would be, here's 1/8, 2, 3, and 4/8. All right, well, if I would have drawn this a little bit more perfectly, you would kind of be able to tell that this is exactly halfway in between 0 and 1. But let's say instead of having 8 pieces, there was only 4 pieces. So let's say we don't have this piece. We'll take out every other one. And actually, let me go ahead and clean this up a little bit. And so we're going to get rid of this line. We're going to get rid of this line, and that's it, right? So, oh no, I did that wrong again. Okay, this line, I got it this time. This line, and this line. If you can use your imagination, I know the squigglies are still there, but we still have 4 pieces. We have 1, 2, 3, and 4 pieces. And so now we only have it split into 4 pieces. So this is 1/4, and this is 2/4. Okay. So it was 4/8 at this spot before. I'll write 1/8 because this is what it originally was here. This point here was 1/8, and now it's 2/4 when we only break it up into 4 pieces. Okay. So now let's go ahead and remove these 2 lines. So remove this line here and remove this line right here. So now we have only 2 pieces. We have this piece right here and we have this piece right here. All right. And so it's split up in half. So this was going to be our first half. So 1/2. And this is going to be our second half. So 2 halves would be 1. So this is not 1/8. This was 4/8. All right, so you can see that was pretty messy there, but you can see that it was 4/8 originally. 1, 2, 3, 4/8 here, and when we cut out half of those spots, then we had 1/4 and then 2/4. It became 2/4, and then when you have it only in 2 sections here, it's 1/2. It's the same point. It was right in the middle, but when we split it up into 8, then the middle section was 4/8. When we split it up into 4ths, the middle section, or the middle point was 2/4. And when we split it up into 2 sections, then the middle point was 1/2. So they are equal. It's always at the same point. It just depends on how you split it up. All right, so let's find 2 fractions that are equal to 2/3. So let's go ahead and do the same as we did before. So see if we can do this a little bit nicer and neater than we did before. So if we have 0, and we have 1, and we have this split up into thirds. So let's do one here and one here. Okay, we have 1, 2, 3 sections. 2/3 would be right here. 2/3. Okay, well, we can kind of do what we did in the last slide, but more cleanly, but in reverse. So let's double the number of sections here. So let's put a section in between here and here and here. So this is double the number of sections, right? Now we have 1, 2, 3, 4, 5, 6 sections. And so that means this is 1/6, 2/6, 3/6, and 4/6. So 4/6 is also equivalent to 2/3. All right, let's cut them in half again. So let's put a line in between all of these here. So if that was in 6, so this must be 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. This would be 1, 2, 3, 4, 5, 6, 7, 8 over 12. So it'd be 8 over 12. All right, so 8 over 12, 4 over 6, and 2/3 are all the same point. It just depends on how you split them up. Oh, and that's it for 4.1 exercises. This is kind of a teaser into what we're going to be getting into with simplifying fractions and things like that later. For right now, this is just showing you that these are going to be equivalent points just based on how you split up between 0 and 1. But we'll get more into that in our future sections. That's it for 4.1. Go ahead and do these exercises, and I'll see you for 4.2.